Okay, so this next video is on speed time graphs. Now this is really important that we don't confuse these with our distance time graphs because the shape of these graphs mean different things, okay? So with a speed time graph, if something is traveling at a constant speed, that means that it's always going to be at the same speed. Okay, so let's say it was at something like, let's say 10 meters per second, it would constantly be traveling at 10 meters per second. So we would get a flat horizontal line. So a flat horizontal line means a constant speed. Okay, whereas if something was increasing its speed, okay, it would have the speed increasing. Now we can have two different ways that happens. We can have an increasing speed where it is doing it constantly, so that would be a constant acceleration. Okay, oops, I'm just going to move my hair out of the way and take, okay, and the other thing that we can have is we can have a increasing acceleration as well. So we can have a non-constant acceleration. Okay, we can also have an increasing acceleration. We could also have a decreasing acceleration. So a decreasing acceleration would be curving off. It's still increasing its speed, it's just not doing it at as fast a rate. So that would be a decreasing acceleration. Okay, that's not to be confused with a deceleration. Deceleration means it's getting less speed. So in this case, that would mean that it was going down. Okay, so that would be a deceleration. Okay, that would be constant deceleration because again, I've got a constant gradient. So if it's increasing its speed, so we can see that the line is going upwards, we have acceleration. So constant acceleration is a straight line. If I'm accelerating more and more and more, so my acceleration is increasing, it's going to be curving upwards. And if it's beginning to curve off, that means I've got a decreasing acceleration. A flat horizontal line means a constant speed, and a line going backwards is a deceleration. Okay, if it's straight, it's constant deceleration. And if it was at 0, okay, along here, that would mean that it was stationary. So looking at the graph, we can start looking at some key points. So the first thing that we can determine from these graphs is we can also recognize the speed because we can just read it off, but we can also determine the acceleration at these points. If I just was to quickly sketch a constant acceleration, okay, and if I draw my graph like this, so let's say I've got my speed and my time, this is showing me a constant acceleration. So I wanted to work out the size of this acceleration. Okay, the size of the acceleration is the same as calculating the gradient. Okay, so I could look at the rise over the run, the change in y over the change in x. Okay, so my gradient, so my delta y, okay, being my change in my speed, and my delta x being my change in time. Okay, so my change in y over my change in x is equal to the gradient, and my gradient is equal to the acceleration. Okay, so one of the things we can calculate from our speed time graphs is we can also calculate the acceleration. Okay, so again, if we see that, we can do the rise over run, change in y over change in x to calculate them. The other thing that we can calculate from a speed time graph is we can also calculate the distance. Okay, and the distance is equal to the area below the curve. And we really like questions like this because it gets students to think. So what we could ask is we could ask you lots of different questions. So we could ask you how far it's gone in the first 10 seconds. I could ask you how far has the object travelled in total. I could also get you to just randomly use different times. So how far has it gone in its journey from 10 seconds to 25 seconds? Okay, I could get you to do lots of different things here. But what we tend to do is split them into shapes. So I'm going to go through and ask in different situations. I'm going to do the first one is how far has it gone in 10 seconds? Okay, we could also, oops, I think I was supposed to do that in the wrong place there. Never mind. And then how far has it gone in its 30 seconds? So that's 25 to 30, so that's around about 27-ish. at that point, maybe like 26.5. Okay, so in this case, what I'm going to do is I'm going to work out these different areas. So we can do the areas of triangles, we can do the areas of our rectangles, and we can also do areas of triangles. So again, depending on what time I wanted. So let's going to say I'm going to find out how far the total distance is. Okay, so in this case, I'm going to do splitting it into sections. I'm going to do section A, section B, and section C. So for section A, okay, I'm going to be working out how far they've gone in the first amount of time. So I can see here they've gone from 12 to 30, so they've travelled at 13 seconds. So I'm going to be doing my half of my base times my height. So in this case, I'm doing half of 10, and my height is 13. So if I just type that into my calculator, so if I just go with 0.5 times 10 times 13, okay, and that gives me that in the first 10 seconds they have travelled 65 metres, okay. In section B, okay, it's just the area of a rectangle, so that's just my base times my height. I've gone from 10 to 26.5, okay, so 10 to 26.5, so that's 16.5, and again, I've still got my height of a 13, okay, so in this case, 16.5 times 13, if I do that again in my calculator, so 16.5 multiplied by 13 gives me 214.5 metres. Okay, so that's in section B. And then section C, again, is a triangle, so half my base times my height. So in this case, they've gone from 26.5 to 30 seconds, so my base is at 3.5. And my height again is 13, and I still need to do the multiply by a half, so I'm going to do 0.5 times 3.5 times by 13 to give me 22.75 metres. Again, this is now my total distance, is all of these three added together, so I'm going to add them all up, so 22.75 plus 214.5 plus 65, so it gives me a total of 302.25 metres, and just to kind of round that, I'm just going to say that that is approximately 302 metres, again giving my answer down there. So that is our speed times graphs. If I was looking at a velocity time graph, it would be displacement under the curve.